In this video, we will solve Chapter 6, Section 2, Chemistry. First question, choose the best or correct answer. If two covalently bonded atoms move closer than a distance of the bond length, less than the distance of the bond length, the potential energy of the atoms will becomes negative, decreases, increases, or remains constant. We know that the potential energy start to decrease till it reaches the bond length and start to increase again. It's the least at the bond length at this point. If you increase or decrease the distance, so the potential energy will increase. Choice C. Number 2. The electrons involved in the formation of a covalent bond are, in the formation of covalent bond, the electrons transferred from one atom to another, found only in the s orbitals, valence electrons in filled orbitals. The electrons involved in the sharing or formation of the covalent bonds are the valence electrons. Bond energy is the energy, number 3, bond energy is the energy absorbed as a molecule forms. A change as atoms get closer together, required to break a chemical bond and form separate neutral atoms, or of two covalently bonded atoms. So the bond energy is the energy needed or required to break the chemical bonds and form separate neutral atoms. Number 4. Bond length between two bonded atoms is twice the diameter of the molecular orbital. The separation at which their potential energy is minimum, the separation at which the motion of each atom stops, the sum of the diameters of each of the two overlapping electron clouds. So, the bond length is the separation distance at which their potential energy is minimum. Which compound most likely has the greatest bond energy? Which compound has the greatest bond energy? HF, I2, Cl2, and HCl. If the bond length between H and F equals 92 picometer, between I and I equals 266, between Cl and Cl equals 199 picometer, and between H and Cl bond length equals 127. Which one has the greatest bond energy? The greatest bond energy, the least bond length. So the choice will be A. The lowest structure of which the following compound does not follow the octet rule. Which one of these? The compound doesn't follow the octet rule. NH3, BF3, CCl4, or H2O. We know that N has 5 electrons, so it will share with 3 atoms of hydrogen. Here hydrogen, 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 so it will form 8 octet rule. Okay. While here B has 3 it will share with other 3 electrons. F. So the number of electrons now equals 6, not 8. So this is the choice, the correct choice. Here C, also C has 4. It will share with 4Cl. So the number of electrons are 8. Here O, 1, 2, 3, 4, 5, 6, and will share with 2 atoms of hydrogen. So now 8. So BF4 doesn't follow the octet rule or number 8 electron. Number 7. In double covalent bonds, one atom has more than 8 valence electrons. One atom loses a pair of electrons. 2 atoms share 8 valence electrons, or 2 atoms share 2 pairs of electrons. Double covalent. Double means each atom share with 2. So the 2 atoms will share with 2 pairs. So the 2 atoms share with 2 pairs, 4 electrons. Which of the following is not a resonance structure of SO3? Resonance structure means exchanging the position of the bonds. Double bond, exchange position with single bond. Which one is not the resonance structure of SO3? The choice will be D. Choice D. Why? Because here S will form bonds with oxygen, not oxygen in the middle. So sulfur in the middle. Here sulfur in the middle, sulfur in the middle, sulfur in the middle, while here oxygen in the middle. The central atom. So the central atom should be sulfur, not oxygen. How many double bonds are in the Lewis structure for hydrogen fluoride? HF. Double bond. You know that? HF. Only one single bond. So none. No double bonds. To draw a Lewis structure, it is not necessary to know the length of the bond, the type of atoms in the molecule, the number of valence electrons for each atom, or the number of atoms in the molecule. To draw Lewis structure, you should know the types of atoms, which atoms, number of valence electrons, and the number of atoms. So the bond length is not required. Okay. Question number 2. Name 2 elements that form compounds can be exceptions of the octet rule. For example, we discussed them before. Hydrogen, because hydrogen has only 1 electron. Boron has only 3 electrons. So these 2 examples, 2 elements that form compounds that can be exceptions of the octet rule. When they form bonds, they do not necessarily form 8 electrons around it. Question number 3. Explain why resonance structures are used instead of Lewis structure to correctly model certain molecules. Why? Because one Lewis structure cannot correctly represent the location of electrons in a bond. They exchange. So each molecule can be represented by more than one Lewis structure. So resonance structure show that one Lewis structure cannot correctly represent the location of electrons in a bond. So we need more than one Lewis structure, the resonance structure. Question number 4. Use the data in the table below to arrange the bonds listed in order of increasing bond length from the shortest bond to the longest bond. Here HF and the bond energy 569, HI 299, HCl 432, and HBr 366. Of increasing bond length from the shortest to the longest. We mentioned before that more bond energy will be less bond length. Higher bond energy, less bond length. So which is the higher one here? 500, 200, 400, 300. So this is the highest bond energy. So it will be the least bond length. So this is number 1. The second one is 432. So this is the second one in the bond length. 366, number 3. And the last one is 299, it's number 4. So the shortest bond length, after it, third one and the fourth one. B. Here, C, single bond C, C triple bond C, and C double bond C. Which one of them is the shortest bond, has the shortest bond length? Which one is the largest bond energy? C triple bond C, 835. So this is the least, or the shortest bond length. And this is the second one and the third one. Okay. Question 5. Draw Lewis structure to present the following atoms: NH3, H2O, C2H2, CH2O, CH4, and H2S. So for NH3, here N, it has 2 electrons and 3 bonds. 2 lone, 1 lone pair, and 3 bonds with hydrogen, NH3. H2O, O has 2 lone pairs and 2 bonds with 2 hydrogen atoms. CH4, C, central atom, has 4 single bonds with 4 hydrogen atoms. C2H2, carbon with carbon, triple bond, and each atom of carbon has a single bond with hydrogen atom. CH2O, here C, central atom, share with 2 double bond with oxygen atom and 2 hydrogen atoms, single bond. H2S, here sulfur atom, like H2O, instead of oxygen, here sulfur. It has 2 lone pairs and 2 single bonds with hydrogen, 2 hydrogen atoms.